polynomial functions and their graphs. Okay, so to give you an idea about what this is about, it's good if we look at some examples. So first of all, we have y equals x, which is a line, okay? And this is what we would call a first degree polynomial. Okay, so it's a line. And there's other, this is more general form, so you could have lines going in different directions and whatnot. Okay, but this is the basic one. That's degree 1. Now if we look at degree 2, and the most basic one is x squared, and that goes like this. Okay, and we already talked about this one. If we have it in standard form, that's a times x minus h squared plus k. And so at any rate, it's going to be a parabola. It could open up or it could open down. Okay, so it could open up or it could open down. It doesn't have to be there. It could be more skinny. It could be more wide, so on. Those are all things that could happen. But it's either going to be like this or like that. And it's going to have a vertex, which if it's opening up, that's going to be the low point. If it's opening down, that's going to be the high point, or the maximum, or the minimum, or the maximum. Okay, so what's gonna happen there. Okay, now next is we look at third degree. Okay, so what happens here? Here's the basic one. It comes up like that, and it kind of levels out, kind of going along. It goes flat actually, right at that instant, and then it continues going up like that. Okay, that's the basic one. But here's the more general kind of form right here. But there's other things it could do. It could actually go like this, where it starts from down and then goes up and then makes a turn and then goes back up like that. Or it could come down like this and make a flip and go this way. Or of course it could do this thing. It could do something like that, okay, which would be like this first one, except just like reflection of it. Okay, so those are what the cubic polynomial can do. Okay, and then the last one would be, well, we can keep going up and up and up, but here's y to the x to the fourth, and that's generally going to be looking like this. Just really flat. I mean, flatter, it's going to be flatter here than this one. I probably didn't even draw it flat enough. Okay, but the more general kind of case is you could have something like this. It could go like that and then down like that, or it could be like this and up like that. That could be another shape that it could take on. It could go, let's see. Let me think here. I think that's about it. It could be really flat but upside down. I'm trying to think if there's another option. Okay, but anyways, at any rate, in all these cases, you're going to have, so here you have these minimums and maximums. Here you don't have any minimum or maximum, but here you got like two what we call local. Like this is a local maximum, this is a local minimum, local maximum. You get there. For these ones, you've got three of these. Like for here, you have two local maximums, a local minimum. Here you got two local minimums, one local maximum. Here you have a local minimum. Okay, so those are different. the situations that we have. Now notice here that with these odd ones, as you go to the right, here it's going up, and as you go to the left, it's going down. Okay, so the right and left are going in different directions. The same with this one. This is going up, that's down. This is down, that's up, that's down, that's up, that's down. Okay, so with the cubes, with the odd powers, you have one side going down and one side going up. With the even powers, they both do the same thing. So here they're both going up, here they're both going down. With the fourths, here they're both going up, here they're both going down, here they're both going up. Okay, so they're doing the same thing. Okay, so with the 4, you have 1, 2, you have 3, what we might call turning points, where it's going up and then it shifts. Here's only 1. There's 3. With the square, you've got 2 of them here. You've got none here. You've got 2 of them here. With the square, you have 1 of these places where it's going down and then switches direction. Okay, so those are some of the things that you can that can happen. Another thing to note is that all these graphs they're all smooth. Okay, so all polynomial functions are smooth when in their graphs. Okay, so let's go to the next. Let's go get into the exercises and just keep some of these things in mind here. Number 1, this one can't be a polynomial because it's got this cusp here. So that doesn't work. And it's not smooth either. So those are reasons why number 1 can't work. Okay, you also can't have a break. This horizontal line test doesn't make any sense because it doesn't have to satisfy the horizontal line test to be a polynomial function. You can have polynomial functions that don't satisfy the horizontal line test. Okay, let's look at number 2, the second part. Okay, so here, this one right here could be a polynomial function. This could be degree 5, by the way. Because you have 1, 2, 3, you have 4 turning points. And it also, this goes down, that goes up. So that could be degree 5. So that one could actually be a polynomial degree 5. Let's see, next one. This one has a break, and you can't have that. So it has a break. Let's see, next one. This one is not smooth here and here. This isn't what you would call a cusp, by the way. These are not, although maybe you'd think they are, but a cusp would be where it's like this. Okay, where it's like totally going in, it just like makes a more sudden change. This is which way it's just like not smooth. That's the only reason that, well, there's other reasons too, that like you can't have a line like that. Well, I guess you could if it's just the degree 1, it would be a line, so that would be okay. If it were completely a line. Okay, now the next thing is with the end behavior. Let me explain a little bit about that. Okay, so this end behavior, it depends only on the highest ordered term. Okay. And let me explain a little bit why that is with this first problem, and we'll just go on to the next ones. Let's say that x is like a really big number. Let's say x is 100. Okay, so then if x is 100, then you're going to have 100 cubed minus 2 times 100 squared plus 9 times 100 minus 13. Okay, so 100 cubed is what? 10. Well, that's like 100. That's a million. Okay, that's like a million. this one would be minus 20,000. And that's plus 900 minus 1, okay, minus 13. So what happens is this one right here, this first term right here is much bigger than this one. I mean, 20,000 is big, but a million is a lot bigger. Okay, and so as x continues to get larger, I mean, if you could make x 1,000, and this would be a billion. This would be a million. This would be 2 million, but this would be a billion, which is much bigger. So as x gets larger and larger, this term dominates right there. And as x goes to infinity, x cubed is going to go to infinity. Okay, so that answer there is going to be infinity. As x goes to negative infinity, x cubed is going to go to negative infinity. Okay, because you have 3 negatives. Negative to the third power is negative. So that's what's going to happen. And then, okay, and then here, so this is going to be negative infinity right there. Okay, now with this one here, with part B, again, we're just going to look at the highest order term. Sometimes the highest order term doesn't come first, in which case you have to like pick it out. Whichever has the highest power here is the one that you want to look for. So negative 9 to the 4th. Okay, as x goes to infinity, then this is going to go to negative infinity. Okay, so that goes to negative infinity. And this one right here, as x goes to negative infinity, well, you're taking it to the 4th power, that's going to become positive, but you got this negative on the front here, so that's also going to negative infinity. And this is consistent with what I said on the first page. When you have an odd power, these two are going to be different. One's going to be infinity, the other's going to be negative infinity. When you have an even power, which is 4 right here, then these are both going to be the same sign. Okay, number 3. If C is a 0, that means P of C is 0. That's what it being a 0 means. And it also means x minus C is a factor of P of x. C is a x-intercept for the graph. Okay, we'll get some more examples. We'll get some examples of this later. Let's go to number 4. Which of the following statements couldn't possibly be true about the polynomial of P? Okay, so if it's degree 3, can it have 2 local maxima and 2 local minima? Okay, so we discussed on the first page, when it's degree 3, it's either going to be like that, or like that, or it's going to be like that, or like that. Okay, and in none of those cases, you have 2 local maxima. You only have 1 local maximum here. You only have 1 there. You only have 1 local minimum here, only 1 local minimum. So this is impossible. Okay, part B, could it have no local minimum? Yes, it can have none. These have none, so this is possibly true. Okay, these ones do have local minimum and maximums. Okay, so that wouldn't be the case there, but it could be one of these two, in which case it would be okay. Part C, if it's degree 4, could it have 1 local maximum and no local minimum? Yeah, that could happen because you could have a situation where it's like that. And that would be a local maximum right there. And no local minimums. That's possibly true. Now, the typical one is where you would have maybe something like this. And you'd have 2 local minimums in this case. Or if you're doing that, then it's 2 local maximums, 1 local minimum. Okay. But this is also possible. So that's possible. Okay, number 5, sketch the graph. X squared minus 9. Okay, so we know that the graph of y equals x squared is right here. like that. And so this minus 9 right here means it's a shift down by 9. Because remember, that's on the outside. On the outside, so it should shift down by 9. So that would be this one right here. Because that graph's been shifted down by 9. Okay, this is inside. So it's a shift to the right by 9. Okay, so the vertex went from 0, it shifted to the right by 9. So that would be this one. That one can't be true. That one can't be. That one's going the wrong way. So it's got to be this answer here. Okay, so this one right here is 5x squared. So the 5 is on the outside. So that will be a vertical stretch. And then this is also on the outside, so that will be up by 3. So you look for the one that's been lifted up by 3. This is the only one that's been lifted up by 3. So this should be the one right here. Okay, this one right here, you have two things going on. So you've got this plus 3, that's inside. So that's going to move you to the left by 3. Okay, and then over here, this is outside. So that's a reflection. That's going to be a vertical reflection, which means it's reflected through the x-axis. Okay, so going left by 3, which would put us over to here, and opening and inverted through the x-axis. So that'd be this one right here. Okay, so none of these have been moved to the left by 3. This one moved to the right by 3. Okay, so here we're kind of putting a couple of concepts together, which is this end behavior. What happens as x goes to infinity? Okay, so as x goes to infinity, again, we're just going to look at this is the highest order term. That's the order 6. This is order 4. Okay, as x goes to infinity, 1/2 x to the 6th is going to go to infinity. Okay, so that's going to go to infinity. And as you go to negative infinity, that's going to go to positive infinity. Okay, because you can kind of think of it this way. If I take negative infinity to the 6th power, the negatives are going to cancel off, right? And they're just going to be, well, that's kind of really weird math, but yeah, it's just going to be infinity. Okay, so what does this mean? Okay, so this right here means if you have the graph, as you go to the right, okay, that goes to infinity, that means you're going to the right, okay? So let me try to break this down for you. So this part right here means that as you go to the right, eventually you're going to be going up to infinity. Okay, and on the other hand, this one right here means that as you go to the left, you're also going to infinity. So it's got to be right there. So what you need is this. On the left, it has to be going to infinity. Okay, not negative infinity, not like that, or like that's okay, or that's fine. And as you go to the right, it's got to also go to infinity. So that's wrong. That's wrong. This could be. That could be. but okay, so so far at this point, we disqualified that answer and that answer and that answer. And oh, I'm sorry, this one too. This can't be down right there. So that answer. So it's between this one and this one in the championship. Ooh, this one and this one. Okay, so now what you do is you look for the next thing after you, once you get the end behavior, the next thing you look for is the zeros, okay? And so let me explain how that works, okay? So zeros. Okay, that's the next thing you're gonna look for, okay? So if I take this right here, I want to find out where is that 0, okay? I can factor a x to the 4th out. I'm going to factor 1/2 x to the 4th out, okay? And that leaves me with x squared minus 12, I believe. No. Minus 6. Okay, so double check here. So this is kind of confusing because what I did here. But if you multiply this 1/2 x to the 4 times this, you get 1/2 x to the 6th. And 1/2 x to the 4 times this one, you get minus, okay, the 6 divided by 2 is 3. And then you have x to the 4th, okay? So this factors into that. Okay, this one gives me a 0 at 0, okay? Which means that it's going to go through here, okay? And these both are fine with regards to that. Okay, this one, if I set that equal to 0, I get plus or minus root 6. Okay, so that means that at root 6 and negative root 6, I need zeros. Okay, I need a 0. Okay, I need a 0. Let me just erase that. This doesn't look good. Okay, so I need zeros there and there. Okay, but this one has them. This is going through -3, so this one doesn't have the zeros that we need. Okay, so that can't be it. So this is the only possible graph right here. Okay, now one thing that I want to point out right here is that this 0 here, this is order 4, okay, because that's to the 4th power right there. Okay, when it's an even order, whatever the order is, this is order 4, it's gonna be like what happens when you have y equals x to the 4th. Okay, so I remember I said when it's x to the 4th, it's gonna be really flat and then do that. Like if it's negative x to the 4th, then it's gonna come up like that and do something like that, right? So it's gonna be either like this or that, and that's right around that 0. And that's what we have, right? It's kind of just going really flat and then comes back like that. So it's like if you like the 0 at x equals 0 in this function right here. Okay. Now on the other hand, over here, you can factor this into x minus the square root of 6 times x plus the square root of 6. Okay, these are order 1. So this will be like y equals x or y equals -x. So this will like just go clean through. It'll just go right through. Okay, we just go right through. Okay, so if you have third order, if it's order 3, then it's going to come up and just kind of touch and go through. If it's order 2, it'll be like a parabola. Okay, stuff like that. Okay, so whatever the order is, that's what the zero is going to look like. Okay, the function is going to look like the corresponding, you know, polynomial with just that at right around that 0. Okay, as you get further out, then other weird things happen, but yeah, right around there, that's what it's going to look like. Okay, so let's move along to the next exercise. So here we have negative x cubed plus 3x squared. 3 is more than 2, so this is the highest order term. And as x goes to infinity, this one is going to negative infinity. Okay, so that's negative infinity. Okay, as that goes to negative infinity, this is going to, you got 3 negatives that are raised to the third power, so that's negative. That's going to be positive infinity right there. Okay. So it's negative infinity as x goes to infinity, and it goes to infinity as x goes to negative infinity. Okay, so that means that as you're going to, this is right, and this is left. So as you're going to the right, it's going to go down. As you're going to the left, it's going to go up. Okay, so this had to be up. So that's wrong. This is okay. This is okay. Well, okay, it's just this is okay and that's okay. Down here, up there. Down here, up there. These are not okay. This is okay and that's not okay. So that means we throw all these out, and it comes down to these two right here. And then, of course, the next thing is the zeros. That's the next one you want to go to. So negative x cubed plus 3x squared equals 0. I can factor a negative x squared out. That leaves me with x minus 3. Okay, so I have x equals 0. That's multiplicity 2. Okay, multiplicity 2 because this power is 2. Because of that power. And this is 3 with multiplicity 1. Okay. So 0, that's good. And here's 3. There should be a 0 there, but it's not. Okay. Here there is a 0, here and there. Okay, now notice, like I said before, when it's second order, when it's multiplicity 2, that 0 is multiplicity 2, it'll be like the x squared function at that point. Okay. Here it's multiplicity 1, so it's just going to go on through that and then go down, and then they continue to go down. Okay, so this will be the correct answer. This is wrong. Okay, so here we have another one, and we're supposed to find the proper graph of this one. Here, maybe it's best if we start with the zeros, since it's factored. X equals 0, x equals 7, and negative 5. So those are our zeros. So 0, positive 7. Okay, so that one's disqualified because it should have zeros there and there. Okay, so that's out. This one does it. This one does all 3 zeros. This one, yeah, it doesn't have the negative 5. This doesn't have the 7. So those two are disqualified. So this is the only one that can be at this point. Now, I was expecting that we would have to go to the next level, which would be this. Okay, so let me just explain that one. If we expand, okay, if we expand all this. Now, you don't have to expand the whole thing. You just look at the x's. Okay, the highest order term is negative x to the third power. Okay, because there's 3 x's. 1, 2, 3 x's. There's a negative on the front. Is that. Okay, so as x goes to infinity, negative x cubed is going to go to negative infinity. So that means as you go to the right, it's going to be falling. Okay, and then for the left, as x goes to negative infinity, negative x cubed. Okay, you can kind of think of it as a negative and then negative infinity to the third. That's 4 negatives, and that makes a positive infinity. Okay, and that, so then it'll be rising as you go to the left. Okay, here, let's see. So this is, let's look at the zeros. So this is -1, and this is multiplicity 2, a -1. Okay, so here's that one. And with multiplicity 2, it's going to be like a parabola there. So that's great right there. -1. That's great right here. Hey, they all got it right. Oh, they all got it right. They're all like parabolas right there. So that's fine. That's fine for all of them. Okay, let's go to the next one. This is 1, and that's multiplicity 3. Okay, so multiplicity 3 means it's either going to be like that or like that. So you look for stuff like that, where it just kind of goes flat and then goes down and goes through it. And goes through it. So, and that is 1. So 1, yeah, that's correct. That's fine. That's fine, and that's fine. Well, they're all fine. How's this? Okay, and then 2 is multiplicity 1. So that's just going to cut right through. Okay. And that's not even a 0 here, so that's out. This one is it's doing good right there for that one, so that's okay. This is not a 0, so that's out too. And this one's fine. Okay, so now we come down to just these two. And so what you want to do is, what's the leading term going to be? So the highest order term. So you got an x squared from here. You got an x cubed from that one. And you got an x from that one. And then you have a negative from that one. So it's negative 2 and 3 and 1 is 6. Negative x to the 6th is going to be the leading term. Okay, so as x goes to infinity, negative x to the 6th is going to go to negative infinity. And as x goes to negative infinity, negative x to the 6th is also going to go to negative infinity, because negative right to even power is positive. And then, but you have the negative right here. So that means that we're looking at this one right here. These are off. These should be going down because they're going to negative infinity both ways. So this has got to be the answer right here. Okay, so P of X, number 10, it says, okay, the instructions are factor the polynomial and use the factored form to find the real zeros. Okay, so you can factor this by factoring an x out. And then factor this other term. This is a quadratic. So let's see, plus 5 and minus 4 works. So the zeros are 0, negative 5, and 4. These are all multiplicity 1, so the graph's just going to cut through at each one. So here, there should be one at -5. This is fine, and also at 4. Okay, so this graph's off. Here, there should be -5, 0, and 4. This is fine so far. And this is now, it should be -5 and 4. It should be -5. Okay, so those two graphs are out. And these two are fine. And then you just look at the leading term as x goes to infinity. X cubed is going to also go to infinity. And that's this right here. And that's wrong. Okay, and as x goes to -infinity, x cubed is also going to go to -infinity because it's 3 negatives to the 3rd power. So this is fine. That's off. That means that's out. This is the graph. This has to be the graph right here. Okay, well, we're running low on time. Okay, let's look at number 11. Factor the polynomial and use the factored form to find the real zeros. Okay, this one is a case of you factor by grouping. So if you group these two together and these two together, look at those as separate things. So from the first one, I'm going to factor out what I can from here. I can factor an x squared out, and I have 2x minus 1 left over. That's from here. From this, I can factor a -16 out, and I've got a 2x minus 1 left over. Okay, so this is just factor by grouping. This is something you learn in like the previous class, intermediate algebra, the class before you take this one. It's just a little technique, which is like mostly not that useful. Well, if you don't get how to do this at this point, this is perfectly fine, because we'll show you easier ways to do later, and you can use technology to help you as well. And we'll go through that, okay? Okay, so the thing to note is that both of these are the same now, and so you treat this whole thing as one term, and this whole thing as another term, and you factor this out of it. Okay, so you have x squared minus 16 times 2x minus 1, and then of course this first guy factors into x minus 4 and x plus 4, and then you have that. So that's 4, -4. And 1/2 are your zeros. Okay, so here's -4. There's 1/2, but there's no 4, so it can't be that one. There's no 4 here either, so it can't be that one. This one has 4, 1/2, and -4, so that could be this one. And this one also has those 3 points as zeros. So wait, no, I take that back. Missing that one, so that's out. It's only this one that can be. And then the leading term, 2x cubed, goes up to the right, down to the left, so that's fine. Okay, number 12. Determine the end behavior. So again, this is the highest order term. As x goes to infinity, -1/2 x to the 3rd is going to go to -infinity. Okay, being that this is positive and this is negative, so it's negative. And that's as you go to the right. And so this is -infinity. And then for the left, as x goes to -infinity, -1/2 x to the cube, that's going to, so you have a -1/2, then you have -infinity to the 3rd, that's going to be positive infinity. Number 13, here you have equation, or you have the graph. Okay, from the graph, find the x and y intercepts. It looks like -2, So the x-intercept's -2, 0, and right there. This one, it looks like 1, 0. And the y-intercept, that's what's going through right here. That looks like 0, -1. You can also get the y-intercept from here, and you have it in this form, because if you set x equal to 0, you're just going to get this last term right there. So 0, -1 is the y-intercept. You can also get it from the equation, I'm saying. Okay, local minimum and maximum. Okay, so for that one, here's the local minimum right here, because the graph is lower than anywhere else, and that's -2. Okay, so it happens when x is 1. So the coordinates here are -1, -2. And the local maximum, that'll be right here, and that's the 0.10. Now, different textbooks define the local maximum or minimum different. So in some textbooks, the local minimum is defined to be -2, and the local maximum is defined to be 0. But you'd say -2, it occurs at -1. This is 0, it occurs at 1. Or you can just put the ordered pair. Other textbooks will define this as it. Or they'll let you, they can let both of them describe it. Okay, let's look at number 14. And what we're supposed to do here is graph this polynomial in this window here. Okay, so let me, let's walk through that here. I'm gonna go to, my GeoGebra. And start the calculator there. Okay, and I'm going to put the function in, which was 2x to the third minus 15x squared minus 36x minus 35. Wait, 36x? Whoa. Okay, now it says, I want the window from -13 to 13. And unfortunately, I don't know how to specify a window here. Okay, but if you zoom out, so they want, okay, so basically what they're asking for is they want, in the x direction, they want to go from just -13 to +13, -13 to +13. So just a small area here. But in the y direction, they want to go from -360, which is down here, all the way up to 180, which is a little bit higher than this. Okay, so, and I don't know how I can do that here. I don't know how I can do that here. Maybe I'm not going to worry about it. Okay, so bottom line is, if I go back to the possible answers, it's going to be, it's actually going to be this one right here. It's going to be this answer here. Okay, because it came up and then went way down to that point there. And this was actually below the, it came up to, So these are the only two that it could possibly have been, because we saw that it came from low, went up, and then down like that. The graph actually kept below the thing. Okay, now let's look for the local minimum and local maximum. Let me show you how to find those from the graph. Okay, so see right here, it peaked out under the x-axis. Okay, so local minimum, if you click that point there, it gives me the coordinates, which is 6, negative 39, negative 359. That will be the local minimum. Okay, and then if I click that point there, then that's going to be that local maximum, -1, -16. Okay, so let me put that on there. So those 2 points there. So clicking that that low point gave me it gave me, sorry, it gave me 6, comma, negative 359. And then clicking that high point, it gave me -1, -16. You can pick up the domain in the range, which is going to be negative infinity to infinity. The domain of any polynomial is negative infinity to infinity. The range is different though, but because we have this going down forever and not going up forever, the range is going to also be negative infinity to infinity.